Okay, so our next topic is going to be calculus. Sometimes it says acceleration is a function of time. Okay, and this is just a way of moving between displacement, velocity and acceleration. So if you've got an expression for one of these, you can move between them. And how you can do that, to go from displacement to velocity, you can differentiate. So if I differentiate displacement, I get velocity. If I differentiate velocity, I get acceleration. Okay, so if you go this way, you differentiate. Then the opposite, so if you've got to go this way, you're going to integrate. So if I've got acceleration, I can integrate that to get velocity. If I've got velocity, I can integrate that to get displacement. What you need to be careful with when you integrate it, always include the c, so the plus c at the end of integration. And then we use the initial conditions to find c. Now what that means is it'll normally say when t is 0, I'll give you some information. You use that by substituting it in to find the c. So basically this way, differentiate, backwards to integrate. And the ways you might see, well, you have to start getting used to the way that you're going to write this then. So if you want velocity, you're differentiating displacement with respect to time, because velocity is differentiating displacement. If you want acceleration, you differentiate velocity with respect to time. Differentiate velocity, you get acceleration. And then the other way round, if you want velocity, you integrate acceleration. Integrate acceleration to get to velocity. If you want displacement, you integrate velocity. So displacement is integrating velocity with respect to t. That's why it's always dt, because it's t in the question. So the question will always have a t in it, so that's why it's respect to t.